the DLMS User Association, to talk about applications of DLMS over LoRaWAN. My name is Rémi Demerlet, and I work for Semtech in marketing for LoRa. Here, as leader of the vertical of utilities for the LoRa Alliance, I'm happy to moderate this webinar where we'll present several companies, EDF, Aclio, Lartec, and Semtech. All these 4 companies are members of the same LoRa Alliance. It's a non-profit organization that specifies and maintains the LoRaWAN protocol used for low-power wide area networks. With more than 135 million of connected devices using a LoRa radio and more than 137 LoRaWAN operators in 150 countries and more, LoRaWAN protocol has become the leading technology for choice in the technologies of low power wide area networks. It was created 5 years ago, so we are very happy to celebrate the 5th year, and it has more than 500 members. So it's the fastest growing ecosystem in the IoT, performing the revolution of Internet of Things. We develop and maintain LoRaWAN across the value chain. The value chain that can be presented with the silicon solutions made of chips or LoRaWAN module that can be used as modem to communicate with a network operated by gateway and LoRaWAN network servers, either by public or private operators. Data are collected over platforms hosted on internet or cloud-based solutions. System integrators are here to create new value proposals, and so far to profit from new applications such as DLMS that can be supported over LoRaWAN networks. There is a wide range of market applications and verticals that LoRaWAN can support. Many verticals in the Internet of Things can profit from the same technology of a network with LoRaWAN. This is the upside of having a great flexibility with an open network standard and to have only one certification specified by the same LoRa Alliance to ensure interoperability across verticals. Among the largest one, the utility vertical stands high in terms of challenges, in terms of a number of connected devices, smart meters, but also other devices that can be useful for protection of relays, surge arresters, pressure, temperature, etc. Requirements are very high because many of these assets must stay very long in terms of duration. The battery life is among the hardest challenge. Gas meters, for example, are battery powered and can combine with DLMS application for utilities. So this is exactly why the LoRa radio and LoRaWAN have been designed and are available today through the ecosystem. Joining us to talk more about these advantages for solutions and application with DLMS, it's my pleasure in welcoming Sergio Lazarotto, President and Executive Director of DLMS Association, Alexander Peloff, CEO of Aclio, Vincent Audebert, Project Manager in EDF, and Vyacheslav Shirikov, CTO from Lartec. In our agenda, the gentlemen will deep dive into the topic of applications, protocol, network deployment. You will learn the liaison between LoRa Alliance and DLMS Association, what is the outcome, what is new. You will learn how the challenges have been overcome, what network impact DLMS can have, and you will see also a very interesting case study supported by Lartec. We'll reserve time at the end of the speeches for the questions. You can write any question in the question box in the menu of Zoom at the bottom of your screen. Now, without further delay, Sergio, I will pass to you the presentation.
Thank you, Rémi. So I am the president and executive director of the DLMS User Association. And this association was founded in 1997. The scope of this association was to develop a protocol at that point in time to be used for smart metering. The approach in developing this protocol was to basically use an orthogonal approach, which was providing independence between modeling of the meter and the application of it, and as well the security features and data transport. Into there, we have implemented several levels of security aspects, such as confidentiality, integrity, authentication. And the DLMS was subdivided, was having subdivided devices to allow more logical approaches to complex devices. In 1999, the first publication was released and was implemented in the first devices. In 2002, thanks to an effort of our association, it was adopted by the IEC standardization body to become part of the IEC 62056 standard libraries. From there, the major activity that the association has been doing over the following years has been mainly to try to deploy this standard onto different type of technology used to for the transport. Initially, of course, it was mainly a wired story where we developed profile for different type of wired technologies, and then progressively we moved into wireless applications. In 2019, this standard, last November, in fact, it has been adopted by the ANSI standardization body in the United States and become part of their C12 suite of standards. So now we are more or less adopted globally around the world. And we have several 100 million of devices installed. So we have demonstrated the scalability of our protocol. We have demonstrated our flexibility. And we have as well demonstrated that it can fulfill the requirement that smart metering is needing. In 2020, DLMS is representing almost 300 members from 70 countries. We have members from all over the world, Asia, United States, also Africa. And what is extremely important, it is that public utilities, because of the standardization, the adoption of our standard by standardization body, international recognized standardization body, our protocol did become more or less de facto the standard that is used today by, or is referenced today by public utility whenever they have to deploy smart meters. Essentially, the implementations that we had were mainly at the beginning electricity smart meters, progressively moving into gas smart meters. And we do have a couple of water smart meter application as well. But it was until today only a topic of smart metering. And of course, this is our core expertise we have built so far, but it has also helped us to build a lot of knowledge and also a lot of understanding on how we can potentially bring these standards to be used into other environments than smart metering. And afterwards in the presentation, I'm going to discuss a little bit of the potential that this standard is opening for different type of applications into other environments. Of course, because of the specificity of what we have been doing, it remains a topic, it remains a standard mainly dedicated to be used into environments which require security, which require flexibility, and of course, which require scalability as well. And this is what we are really strong at. Vincent? It's your turn.
Thank you, Remy. As a large utility, EDF thinks that if you want to go to this new world of IoT, we need to scale. And when we think of scaling, we think of standards. So EDF, for a long time, is heavily involved in standardization. I can even remember in the beginning of the 90s, I was working to standardize DLMS. So on one side, we are a member of DLMS UA, so for a very, very long time, with objects that are targeting our business of the utility world. And as already said by Sergio, it's something that works quite well with hundreds of equipment running at the moment with DLMS. But as a telecommunication engineer, working for a long time in the utility field, we understand when the LP1 appears that it was a missing link for a lot of interesting things we want to do. And so that's why, since the beginning of the Alliance, just after it was founded, EDF moved to LoRa Alliance to have a more refined standard that will fit our needs of utilities. And so it was normal for EDF to be, as we were on the two different associations, to be a liaison sponsor inside the LoRa Alliance to establish the liaison between LoRa Alliance and DLMS UA. And since it was something that could be more complex, we think that we had to engage with another standardization body, and it is what is described in the slide. Next slide, please, Anna. So how did we decide to work on this very interesting subject and working equipment with DLMS COSM, discussing with LP1 standardized by LoRa Alliance? The idea was, it's something that have to be built on two sides. First, to discuss on how this technical evolution can benefit to both associations. So I will say communication and marketing discussion, to be sure that we were spending time building something that will bring value to the utility business. And also, how could we do that? And the idea was, after the first discussion, that we could do leveraging on a work that was started a few years ago in IETF. So IETF is standardizing everything about IP. So it's how to use IP on top, how to use IP on top of LP1 networks. And so this solution called SCHC, SCHC, has been decided to be the conversion point between the two technologies. So the DLMS technology, DLMS COSM technology, and the LoRaWAN technology. And so it has been more than 2 years of hard work to be sure that we will have a DLMS profile working on top of SCHC that is running on top of LoRaWAN. And we are now reaching our goal, and it's going to be integrated with other things inside the Blue Book. And I leave the floor to Sergio to explain what is in the new Blue Book.
Yeah, so before I move to discuss a little bit about potential application of our standards, in DLMS, we have books which are used to bring into the market our specification. So we have the blue book and the green book, which are basically defining the objects that are defined depending on the type of features and applications that we want to have. And we have the other one, the blue book, that is the protocol itself. Then we have as well the yellow book, that is the book that allows to our members to perform themselves the test for the certification for compliance by using tools that are proprietary to the association. In the next release of our Blue Book and Green Book, which will be the release 14 of the Blue Book and the release 10 of the Green Book, which are scheduled around July, August, we will implement a certain number of things. And among those new things that we are going to release, they are the low power wireless profiles, so that it will open up a complete new era of application of the DLMS COSM protocol, in particular the use of our protocol on WISON, and of course as well on the NB-IoT and the LoRa technology as well. And these for me are major breakthrough, because the fact that from now on our members, the users of our protocol, will be able to port our protocol into those type of low power wireless technology will open up certainly a completely new world of different type of applications that will go far beyond the smart metering into which we have been successfully deploying so far. In the next slide, I'm summarizing here the world that we are planning to basically play a major role inside. And this is thanks to this convergence of low power wireless technologies that have certainly demonstrated their maturity in diverse type of applications. But as well, this convergence goes with the fact that, of course, we are finally able to deploy DLMS protocol into those wireless technology. And not only we are permitting this combination of our protocol on top of these low power wireless technology, but we are guaranteeing the security from the top on the application down into the device with the most modern type of security features that are available, such as the CNSA and the NSA type of security. But as well, what we are enabling is an IP link from the top of the application down to the device. And I guess that this is a breakthrough that will, of course, permit us to bring our expertise and enable our members and all the companies that will want to use our protocol into different type of application. And the type of application that we are using, of course, it's always energy related, but it's not only anymore to measure electricity, but it goes a little bit further down. And this is what we are looking at. It is to expand the use of our protocol always into the energy market, energy and water market, but also for doing things which goes beyond what we have been doing so far. And here particularly, we are going to look at monitoring and control. We are going to look at typically markets such as the mobility market, the way on how to handle the demand response so that we are capable to bring an answer to the public utility that are concerned on how the energy is used and particularly how the energy peak demand can be up to a certain extent kept under control, particularly if we are thinking of electric mobility, which is going to be a major topic of discussions in the coming years. So this is something that is very important to us, and we are organizing the association as well in order to be able to take those challenges and bringing answers to our existing members, but also opening up the association to give some reasons to other companies that are not necessarily smart meter manufacturers to join us and work with us in being able to define usage model of our DLMS COSEM protocol for other type of market. And this is not only for the residential or the in-home type of use, but it is also true for commercial application and industrial applications. And I guess that's this convergence with low power wireless technology, for me, it's an essential breakthrough that will open up a completely new era. Alexander, up to you now.
Yes, thank you very much. Thank you very much, Sergio. So hello, everyone. My name is Alexander Pelov, and I am CEO of Acleo and co-chair of LP1 Working Group at GITF. So today I'm going to walk you through in a couple of slides on the technical feasibility, like some of the technical details of how it is actually possible to make, to run standard DLMS over the LoRaWAN technology. And here, of course, one of the first questions that comes up is, well, you know, we have some restrictions, restrictions in bandwidth and duty cycle and dwell time in some of these technologies. And actually, the real problem here is how do we provide seamlessly all the DLMS mechanisms at scale? So when we deploy tens of thousands of hundreds of thousands of meters. Well, there are actually two parts of the response, of the technical response that are provided, and here you have the two bullets. So the first one is actually we in the work of the DLMS profile, it is to reduce the bulk of the exchanges that are happening on regular basis. So basically reuse everything that DLMS allows, but use it a little bit more intelligently. And this is by first using pre-association and then using push messages to optimize the media usage. So in that sense, for example, if you have a meter and the meter is reporting data every day, for example, on a regular period, well, you don't connect to the meter every day to request it to send you the measurements, but you know, you configure the meter to send you these messages every day. So it's the same, you get exactly the same benefit, exactly the same usage of the meter, but in a little bit more smart way. So that is the part of the DLMS profile. Then again, we have the IP-based connectivity that allows for seamless use of all DLMS mechanisms that are already present in the technology. And this is happening thanks to the IP connectivity, more specifically to the static context header compression, which is abbreviated SCHC, or pronounced SCHC because otherwise it's unpronounceable, and which is now official standard. It is RFC 8724. And so to give you an overview of what the technical solution, so the LoRaWAN profile for DLMS, what it actually provides. First of all, it supports all services that are supported by DLMS and that you already are used to. So you can have commands to the meter, you can have bidirectional connectivity. Of course, like the bulk of the information, you're going to be moving on to push notifications, but you can use everything that you have been using already. Secondly, we keep the full security that is already present in the DLMS, and that's a really important part. To have this fully supported, and we actually use the full security part of the LoRaWAN stack, and we do support in this profile firmware update over the air, and that as well here we have the collaboration of the two associations that may happen. So using standard multicast technology that is already present in DLMS, that's already present in IP, and that is also present in LoRaWAN. So that's really the big picture here, is to say, well, by taking these two elements together, working them really nicely, we provide seamlessly all DLMS mechanisms at scale. And of course, it will be part of the DLMS certification. Now, when we have this big picture, I'm going to dive in a little bit more in how do we actually interact between the meters and how do we provide this seamless use of all mechanisms in DLMS. First, we'll look at a typical communication between a device you have here on the left-hand side of the device and a head-end system on the right-hand side. So when they are communicating, typically you will see, if we look in, for example, in the device, you have the application, the device application that is using the DLMS cosine representation and protocols, and they use the IP stack. Then you have IP connectivity communicating to the head-end system. So we are really going to be looking into, for the rest of this presentation and for the solution that was standardized, we'll be losing at IPv6 over UDP. So here as well, when we are talking about IP connectivity, we have everything that comes with it. So we have the addressing, we have the management of the system. And you know, when you have a device talking over IP, it's the underlying technology, it's really the thing that you need to worry the least. So how is that possible? Well, let's look at the other side, the other part of the communication stack. So we have the upper layer, and now we have the LoRaWAN network. So a typical LoRaWAN network, you will have on the device side, you will have the LoRa physical layer and the LoRaWAN MAC. So they work together to send the messages over to a LoRaWAN gateway. All these messages are then processed by a network server. And they are like really, really great when you work in a pretty raw mode. So you send data between two nodes. Now the point is, how do you actually make the link between the services provided by the IP layer and the LoRaWAN MAC? And this is the part where the SCHC technology, the SCHC compression and fragmentation, comes into play. So that technology actually resulted by a major innovation made by Aclio a couple of years ago, like it was, I think, 5 or 6 years ago. And it has been some time until we actually got to the point where we have all the features and it is perfectly working. So on the device side, we have the stack that does the compression and the fragmentation. So that means that you have all the services of the IP layer, but with almost zero overhead over the radio. So that is really important to not waste bytes. In addition to that, you have the fragmentation part that actually makes a very intelligent way of handling messages over the radio. So it adapts, for example, in Aclio stack, it adapts to dynamic change in the radio conditions, it adapts to deployments, it adapts to different ISM regulations. So all that is in the standard, and it goes into in that layer. When the message is sent over to the LoRa network server, well, it is sent to a SCHC gateway. So that is a core element that in the LoRaWAN terminology, it is the application server. And the SCHC gateway, actually, it performs the other side of the equation, the equivalent. So the decompression and the defragmentation, or vice versa. And it makes sure to have this, to provide this IP connectivity from the meter or from the device to the head-end system. So if I need to sum up here in one slide, you have all these protocols and all these different technologies that are working in different levels. They are like an orchestra, and they're working in harmony. So IP is the typical convergence in the internet level, and the SCHC technology, that is RFC 8724, is the one that makes sure that the LoRaWAN ecosystem is now part of this orchestra. And so when we look at how things are actually working together from organizations' point of view, You have that the DLMS user association that is specifying the DLMS COSEM layer. You have the IETF that is standardizing in the world, that is standardizing the IP layer and the adaptations such as SCHC. And you have the LoRaWAN, the LoRa Alliance that is standardizing the LoRaWAN technology, the LoRaWAN layer. So the three technologies that are the only ones in the world that are actually making these specifications are working together. And here they have brought you the solution of actually of how they all will be working together. So where does that leave us? Well, it leaves us in a place where we have end-to-end application. You have the meter on one side, the head-end system on the other, and you have a standard-based, efficient, and optimized IP connectivity over LoRaWAN. So you can use everything that you know about DLMS for individual meters. If you want to scale up, you have everything that you need in the DLMS profile. Basically, it is really the way standards and this technology is expected to work seamlessly and at scale. Now I'm going to actually show you how this is working. I have a short video that is presenting a demonstration. So this is a live. So this is a recording, but it was run on a live LoRaWAN network. So here what you have is a head-end system or a demonstration of a head-end system on the right-hand side. And it is connecting to a smart meter over a LoRaWAN network. The point here is that we really wanted to show any DLMS exchanges. So we picked up something that is really talking to everyone. Connect to a meter, and then read the meter catalog, and then one by one, read all the indexes. So here in the middle section, you have the IP communication. So this is where so typically here you have an IP router, and they are just exchanging IP packets. So here on the right-hand side, you see the DLMS messages actually that have been sent, and to the left-hand side here you have the SCHC stack. So in the middle here you have the Aclio SCHC gateway that is actually doing all the magic between bridging the IP layer and the LoRaWAN layer. And so here you can see the compressed packets, the compression, the decompression, the fragmentation happening live. So we can see that you have big messages. It's absolutely no problem. And the point here is that the head-end system here on the right-hand side, it doesn't need to make sure about regulatory specifics or radio conditions or anything. It's just speaking plain IP, and you can use any head-end system here. And on the other side, well, you have a standard meter that is speaking DLMS. So here you had an example the video is over of a bidirectional communication that was interactive between a head-end system and a meter happening. So the DLMS was not touched at all, and all that happening over SCHC. Now the point is that here you have the illustration that it works seamlessly, and when you take into account also the DLMS profile and the whole solution that will be published in the Blue Book, then you have the system working at scale and with everything available to you. With that, I think I finished the explanation of this part, and I'll be happy to answer you a couple of questions later. And I'll get back to you, Rami.
Thank you, Alexander. So we have seen that journey from the ambition to overcome the challenge of DLMS being standard over IP, and the also flow of data that needs to be supported. And for, I would say, a number of players, it was a joint interest to perform demonstrations. 2 times, a group of companies in European Utility Week and last October 2019, and recently in India for a Smart Utility Week, they have presented a demonstration with devices, meters, also line fault detection, for example, and other IoT devices that can be used for airports. So different devices connected on same LoRaWAN network using indeed the SCHC adaptation layer supported over LoRaWAN either communication module as made by a microchip, for example, or also with Aclio support and with CARE for line fault detection, etc. So these demonstrations were achieved in public events to present how the devices can have, for some very heavy communication data to be sent, or for some to send frequently, like meters, or others like line fault detection only on case of specific events. So these companies are at disposal for, of course, new effort, new implementation, and will continue their journey to support the new profile. In next slide, we are touching one of the, of course, most common use case of application with DLMS, electricity metering. Let's take an example provided by Aclio for an electricity meter, a single phase meter that will communicate every 30 minutes power consumption. So to speak, the load curves, different meter readings, log books, plus also in case of alerts, alarms that can be necessary. On a daily basis, in average, for a large number of meters, and the average daily volume of traffic is around 1,440 bytes. So we consider that Semtech how to evaluate the simulation with a simulation model that Olivier Seller introduced during the conference in Amsterdam at TTN. And where, with his support, I will present a few slides to share results of this interesting simulation. The simulation in next slide will present how this kind of number of electricity meters deployed in urban areas, and we will see after in suburban areas, are, I would say, communicating, and what could be the maximum capacity that a LoRaWAN network can here support. From left to right, we see the increase of what is called the gateway density. How many, I would say, gateways actually are on a square kilometer surface. For example, on the right, 2 as a density number indicates that gateway will be in a space of on 700 meters each as a spacing. On the left, they are very far from each other, about 5 kilometers, for example. So it's I would say evolution of the maximum capacity in terms of number of end devices. And we've considered here one gateway every kilometer to make it simple as the red spot, and to evaluate what would be the capacity, depending on, I would say, 2 factors. In urban areas, the most part of the traffic will be supported in that case with the fastest data rates called spreading factor 7 and 8. And with that model, simulating propagation, losses, etc. in urban area, we can see that a certain number of transmission have a direct impact on the capacity from 9,000 to 23,000 and more. It's very interesting to see that the number of repeats helps to communicate with the network for each meter. At the at the result of this simulation, our best practice recommendation is to use the repeats that are decided by the network operator. They will be very good in improving the network, I would say, efficiency. You could have also more and more gateway, then you will improve the gateway density and you will scale up the network capacity. Let's see now how these spreading factors are supporting the communication of meters. In the next slide. We see for the same number of density, 1 per square kilometer, the spreading factors 7 and 8 are indeed supporting almost all of the network load, 97%. The remaining part will be supported by the slower data rates. And if the network density was less, then we will have gateways separated farther and farther, and then density decrease. That means there is a need for slower data rates to reach meters, and this will be the limiting factor. What usually operators are observing is the consumption of the slowest data rate, SF12, to allow a network to be efficient. For example, one rule of thumb can be to avoid that more than 10 or 5% of SF12 are used. And here we give that indication. What does it mean in terms of network density? We have done that simulation too for a suburban area, but this, I would say, is exactly following the same method. These tools for network simulation can be discussed on one-to-one. We continue our effort to make simulation. We don't replace discussion with network operators. And we also support any system integrators or meter vendors or utilities that would like to evaluate and consider what are the theoretical limits of simulation. So now, to continue further on, I will hand over the next part to a very interesting use case where Vyacheslav, CTO of LARTEC, will share their experience with use of DLMS. Vyacheslav?
Thank you, Remy. Hello, everyone. I'm Vyacheslav, the CTO of LARTEC, and I'm happy to present our hands-on experience on the DLMS meters on fields and how it is done. So LARTEC is, I think, the leading LP1 smart metering solution provider in Russia. As you can see on this nice map, we have a lot of gateways over the Russia, mostly in central Russia and in some Siberia regions, and very few on the Far East. We have our own LoRaWAN network server and LP1 smart grid application server, which we provide as cloud service or as an on-premise installation. Here in Russia, we have DLMS and its Russian flavor SPODES, which is basically the DLMS translated into Russian, and with some obvious codes are fixed and named conveniently to Russian engineers. So this DLMS is a mandatory requirement set by Federal Power Grid Operator. And in LARTEC, we built this DLMS solution from the radio module. So we produce radio modules. We write the firmware for the radio modules. We write the server side, and we write this application server. We have three modules of the meters with DLMS. The first one is the L Gamma 100, Gamma 300, which produced in Latvia and in Russia. Incotex Mercury M203, 234, which produced in Bulgaria and Russia, and the Russia specific Enagrammy России 208, 308. For our customers, the common profile of data collection is follows. Every 30 minutes, we send from the meter. We always use only the push notification because, as Alexander speaks earlier, it's the only way to have the scaled smart meter networks. Without it, it's not feasible to send up that many data. So we have power consumption and quality indicators. Of course, we send alerts and some journals if something is changed on the meter, because sometimes the meters are trying to break into, and some guys who are not willing to pay shortcuts the wires and try to bypass the meter. And all this stuff are extremely important for the power grid operator to know at the moment when it happened. So it goes around 100 uplinks per day with power consumptions, quality indicators, daily consumption. So it totals up to 6,000 bytes per day. We also support bidirectional channel, of course, because it's important for the relay management on demand. And this slide shows the bit more details about our solutions. Our smart meters are done following by Blue Book, the previous version. So all these solutions are built without SCHC, but all the concepts of the SCHC are, or maybe almost all the concepts, are tried and proved to be feasible. And well, it's a great thing that now we have this standardized, and all other guys are needing to done everything from scratch and use these RFC specifications. So our solutions allow us to, well, this is the first DLMS over LP1 solution approved by our federal grid operator. It allows to have the mix of DLMS meters and the simple meters, because on the application server side, we mimics the DLMS for the previous legacy meters. And for the economical comparison, we have our typical installations with 50,000 smart electricity meters installed in 500 multi-apartment buildings. So for comparison, we have some experience in ZigBee, and the PLC figures are provided for us by the PLC meter vendor, and LoRaWAN, it's from our own experience. So the first big difference, as you can see, is the number of gateways. The usual practice for the old technologies is to put the gateways for one building exclusively. For ZigBee, it's due to limitations of the mesh network and the length of the wired signal. And for PLC, it depends heavily on the wiring of the electrical wires. So usually it doesn't work when PLC gateway is somewhere other than the exact building. For LoRaWAN, we have 1/10 of this to cover all the meters, and well, it's very important to have low capex on these installations. The reliability of the uplink channel, of course, for LoRaWAN is much better, as several gateways can collect the data. Another wonderful thing is the complexity of installation and setup. For the LoRaWAN, it's zero additional costs for the meter because it just applied on its regular place and it's already sends the data to the network. And it requires no additional setup on the place, so very low qualified personnel could install these meters. This is not true for the ZigBee. It's very hard to install the correct mesh network in a multi-apartment building. You need some routers, you need to have experienced personnel, and it's take a lot of time and effort to set up a network for the 1,000 meters in one building. For PLC, it's of course the installation is also very simple, but the setup takes some time and effort as well. So if you combine these figures, the new LoRaWAN meters appears to be cheaper than the ZigBee or PLC because of these additional costs are close to zero. Well, so we can see the total capex of this example rollout to be very low for the LoRaWAN, a little bit higher for the PLC, and much more higher for the ZigBee. And we can take into consideration the connectivity for the backhaul of the gateway, and because of this and very small amount of data, and we operate in a push mode, not the pull for the ZigBee and PLC. So we have this TCO for 5 years of exploitation of the system. It's 2.8 million euros, and for PLC it's almost 20% larger, and for ZigBee it's 42% larger. For our customers, it's a non-issue to choose the LoRaWAN technology. Of course, it was a lot of caution to the new technology, but when the economy talks, it's quite obvious that the new way of approaching DLMS meters in combining with LoRaWAN, for now, when we have this standard in the Blue Book, it will be much more efficient, money-wise and installation-wise and exploitation-wise.
Thank you very much, Vyroslav. Sorry, you wanted to add something, but we are rushing after time. So to put conclusion here, the takeaways we want to share with all attendees. First of all, it's a combination. It's a combination of different words. The DLMS world that is well known in smart metering, and the IoT world with a leading technology of LoRaWAN. So we built a new profile that is based on these two worlds to allow end user to leverage on their, I would say, on the interoperability and the reliability with a key standard approved. The two vast ecosystems are backing up this new profile. So DLMS over LoRaWAN has to be released next summer, will ensure that it's secured. It provides full reliability and benefit of interoperability with certification across the two associations. So end user can protect their long-term investment with the benefit of things being standardized. But also, it's not only for smart metering, that's also the key message. You could use DLMS for many other new applications, mobility, charging stations, smart grids. You could use also this in many markets areas where DLMS/COSEM have been already approved by local regulation. No doubt that they will follow the Blue Book release and adapt this new profile. Last but not least, the case study presented by LARTEC is proving that the DLMS over LoRaWAN works well and has a cost effectiveness versus other legacy or older technologies. So now we have reached the end. I wanted to pass a last message. This year is the 5th year of anniversary of LoRa Alliance. We wanted to tell you by next December 3rd and 4th in Paris, you're welcome for joining us in this LoRaWAN World Expo, the first of that kind. Many panels, conferences, but also booths will be very smart to be visited by companies of all, I hope, over the world, if we can make it. This is confirmed, available for registration. Agenda will be published very soon, and you will see a lot, including a session about DLMS application, of course. And now we will begin the Q&A session. I can tell you we have seen more than 42 questions already. 16 have been answered, so it will be a challenge to go over all. But also I wanted, as I would say, a beginner to place first questions first for Sergio for DLMS Association. Could you tell us more about what is your ambition beyond the smart metering to use DLMS profile over LoRaWAN for other applications?
Well, definitely, as I said during the presentation, until today, we have mainly used our protocol on devices that were for smart metering. And this is no doubt that we are by far the standard that has been the most deployed in the world for those applications. But it is clear that the fact that there has been this convergence of low power wireless technologies that have converged to a level into different type of market, have demonstrated their capabilities of scalability and also their quality of communication. It is clear that this is opening up a completely new world. Now, the fact as well that DLMS COSAM is up to a certain extent communication transport layer agnostic, having the different profiles that are offering the possibility to implement DLMS COSAM on devices using different wireless technology. And of course, LoRaWAN is one of those, is going to be beneficial for all of us. And clearly, many applications where typically, give you an example, health and usage monitoring system of networks, whether it is a water distribution network or electricity distribution network, or eventually gas distribution network, where it was extremely difficult to power wireless devices with batteries that could have a long-lasting life. And by the way, speaking DLMS as well, now this is feasible. And the degree of security that we are offering with our protocol will enable our members to create those networks that will effectively guarantee a high level of security among all the communication network from the devices up to the application. And I guess that this is something that is extremely valuable, and definitely it is something that we are looking very carefully. Another aspect is the demand response. The demand response is something that becomes more and more important because the distribution network for basically electricity, it is what it is, and it is going to be very expensive and takes a long time to increase the capabilities of the network to transport more energy. So we have to use this energy in a more intelligent way. And this degree of usage, intelligence usage of the energy that is consumed is something that, thanks to what we are going to offer, will become possible by having this wireless connectivity with appliances, wireless connectivity with charging stations for electromobility, and so on. So all those markets are markets that we are looking very carefully, and we are as well planning to organize our association in the appropriate way to be able to bring appropriate answers to each one of those markets that do have very specific needs.
Thank you, Sergio. To also continue, I wanted to ask to Alexander about the other usage of SCHC. Could you describe other IP-based application protocol that can be supported in same, I would say, in same inspiration?
Yeah, yes, of course. Thank you, Remy. So of course, the goal of SCHC is to enable IP over LPWAN, and IP over LoRaWAN works really beautifully. So we have already showcased when you can use Modbus over IP, or you can use lightweight M2M. Basically, any IP-based protocol that does not require gigabits of traffic can run in a pretty straightforward way by using, for example, the drivers and the software that we are writing. So SCHC is the way to bring the internet into the LoRaWAN technology, and once you have that, then you have all the services that are there for you.
All right. There was also the question about the 6LoWPAN in the flow of questions.
Oh yes, thank you. Yeah, I actually answered by writing one of the questions about 6LoWPAN, but I will give you. So 6LoWPAN is like a compression technology for typically it was created for mesh networks, and it was designed as such, like multi-hop networks. So it does a great job for this type of networks when you have the number of you have intermediate routers, and you have some specificities of these types of networks. And when you get 6LoWPAN and put it into an LPWAN network, well, then suddenly things are not working so great. So this is why we actually designed SCHC in the first place. So I mean, if I go back 6 years ago when in Aclio we started working on the technology behind SCHC, the first thing that we actually did was we went to companies and we say, hey, use 6LoWPAN. And we talked with these companies, and everything that we got back was, well, it's not working for that reason, or for that reason, or for that reason. So we had our design space, right? We need a technology that can run IP-based protocols, that is efficient, that is really compressing really well things, that adapts to the radio communication, that has fragmentation, that can, like, things that you would basically need to redo 6LoWPAN in order to get that. And this is why the IETF actually accepted to make a standard of this. Like, the IETF does only does standards and new technology if they have absolutely to do so, if there is no other way to do that, to achieve that goal with the existing technologies. So this is, I'm trying to keep it short, but there was a very, very long discussion at the IETF, and I can provide a pointer to that if you wish later. Thank you, Annie.
Super, and if necessary, we will add into the written replies. One also question for Vareslav. The reading rates in your deployment in Russia, can you share with us measurement of performance you have?
Yes, so we have an SLA with our clients, which demands that 95% of data should be available at the meter data management system within 1 hour, and 99% should be available within 24 hours. Yeah, because, well, 100% is non-achievable. Some meters could be switched off, but 99 is good enough for everyone. And my experience with ZigBee, which I was doing like 10 years ago, give or take, we could achieve like 95% at all, and it takes a lot of effort to support the mesh network to have the possibility to collect the data, which in case of LoRaWAN it's not needed, because without mesh all the bottlenecks of the mesh are gone.
Okay, so you of course are good with this SLA that you can support. For ZigBee, you said 95 max.
Yeah.
Okay. I wanted also to ask a generic question. If I have a DLMS meter, today without the new profile. Can I use a communication module to connect it to a LoRaWAN network? What would be your first reaction, Jaroslav?
Yes, you can. So with our firmware stack and our application server, you can connect any DLMS meter. Well, I think in a week. You need to provide and to write down the OBIS model for this meter to be on the module and to be on the application server side, and that's it. All other software is tested and ready and operational.
And of course, with the future release of the Blue Book, Sergio, what would be your advice to migrate and adapt perhaps for the new profile?
You mean in terms of existing implementations?
Exactly.
Well, my first feeling is that if you do it through an external module, it's going to be extremely difficult because the system is not optimized in terms of communication beyond the implementation itself. So like this, I have a little bit of a hard time to really see that. But definitely, I can look at it in more detail with the specialist we have in house, and eventually come back with a more precise answer. But as a first guess, I'm not sure that having an old smart meter that connects through a serial interface with an external module, I'm not sure it is going to be an optimized solution. It will work, but I'm not sure it's going to be an optimized solution.
I have also another question. We have many participants from India, and of course, the Indian Bureau of Standard has use of DLMS since long. There are questions about how this new profile will be covered by the Indian standard.
And I'm just answering now on the questions online. So in fact, the standard 15959 in India is inheriting the IEC 62056 specification, which is the suite of DLMS, and we are regularly updating the IEC 62056. Therefore, anybody that is complying with the 15959, de facto, they will comply with DLMS.
Thank you. Another question for we are getting to I would say to exceed the timing, but let's say we would use already most of the time for a question. The remaining question will be managed by written and we should be shared with the attendees. But just before finishing this, Vincent, could you tell us more about what application existing or new of DLMS over LoRaWAN you can envision for EDF?
Sure. You can see that we are moving in a world of smart grid. And so you need to interact with equipment to have better coordination between consumption and production. And so that's what we are thinking, to have better view of the smart grid network also. As it's been already mentioned, there is a nice demo that has been done with equipment from Cahors that are detecting fault on MV networks. And this is one of my favorite use cases, one of my first tests that I have done. I think it was 5 years ago, because it's equipment lost in the countryside that are battery powered. So it's a very good solution for this equipment.
Yeah, you mean a typical application that need battery-powered sensors in far isolated areas can be, I would say, good value for ER4EDF to be connected with a LoRaWAN network. I'm very grateful to all the panelists. I think it's time now to close this webinar. I want to give a warm applause to the panelists on the behalf of the attendees. We were more than 150 participants at certain point of time during the webinar, so it's very impressive. We will communicate update with the white paper, and also we will provide all answers that have not been touched during the webinar. Thanks again for your attention, and thanks to all the panelists.
Thank you. Bye-bye, everybody.